All right, here's the second half of the worksheet. The first question in the second half, what do you get when you try to find the derivative of this guy? Let's give this guy a name and we'll call him f of x at x equals 3. Okay, doesn't tell me how to do it, so I can do whatever I want. F prime of 3 is equal to, let's use the definition of the derivative. You could do this with the difference quotient as well. The limit as x approaches 3 of f of x minus f of 3 all over x minus 3. Absolute value of 3 minus 3 is the absolute value of 0, which is 0. So really what this is asking for is what's the limit as x approaches 3 of the absolute value of x minus 3 over x minus 3. I think we've already seen this one before, but we'll go through and do it. When you're trying to evaluate the limit of an absolute value sign like this, what you got to do is look at what's the limit as x approaches 3 from the positive side of it, and what's the limit as x approaches 3 from the negative side of it. And so as x approaches 3 from the positive side, x is a little bit bigger than 3, so a number bigger than 3 minus 3 is a positive number. So since the top is positive, the absolute value signs aren't doing anything, so we don't have to write them. So it's just x minus 3 over x minus 3, which is 1. Evaluating the limit as x approaches 3 of 1 is just 1. See, over here, it's a little bit different. Now 3 from the negative side, so this number is less than 3. So when you subtract 3 from it, you get a negative number. So what the absolute value signs are doing are switching the sign of what's on the inside here. And now those cancel out and I get negative 1. So what I'm getting is a different limit when I approach from the positive side as I get when I approach from the negative side. So this limit does not exist. And you might wonder if that makes sense. I guess I asked, does that match your conceptual understanding of a derivative? It does. I'll show you why. So if I graph this function, the absolute value of x is kind of the V graph, but this minus 3 shifts it 3 places to the right. So it ends up looking like this. And my conceptual understanding of a derivative is the derivative f prime of 3 is saying what is the slope of this point. And so slope of tangent line here is what we're solving for. And that doesn't exist, right? You can't have a tangent line at a sharp curve like this. Here does not exist. So yeah, it all matches up. Okay, number 5. Let's see, asked to find f prime of a. So I think, is this the first one where I actually find f prime of a? I think it is. So what's going on here is two things. It doesn't tell you to use the difference quotient or the definition of the derivative. And then furthermore, it doesn't even give you a value. So it's not saying just find f prime of a. Turns out that's all okay. We can do that. So you have the option to use the definition of the derivative or the difference quotient. I'll use definition of the derivative just because I got to use something. Limit as x approaches a of f of x minus f of a over x minus a. So f of x is x plus 1 over 4x plus 3. F of a is a plus 1 over 4a plus 3. And on the bottom I have x minus a. All right, I want to be able to make this one fraction. They have different denominators, so I'm going to multiply this side by 4x plus 3 over 4x plus 3. And I'm going to multiply this side by 4a plus 3 over 4a plus 3. Because that gives me a common denominator up top, a common denominator of 4a plus 3 times 4x plus 3. And in the numerator of the numerator, I have 4a plus 3 times x plus 1 minus a plus 1 times 4x plus 3. Big mess. And then that's all divided by x minus a over 1 if you want. All right, FOIL these guys out. You get 4ax plus 3x plus 4a plus 3. And from that, subtract, FOIL these guys out. You get 4ax. And then you get plus, let's see, 4x. And then you get 3a and 3. Oops, sorry about that. And then that is all divided by 4a plus 3 divided by 4x plus 3. And that's all over x minus a over 1. Where to go from here? Maybe I'll jump down. From here, I'll go over to here. Okay, in the top here, I have 4ax minus 4ax. It's kind of nice. Those guys cancel each other out. I have 3x minus 4x, so I got a negative x. I got 4a minus 3a, so I got 1a. Then I got 3 minus 3, so those cancel out. And then I got 4a plus 3 over 4x plus 3. And then I want to divide by this. That's the same as multiplying by x minus a. So I can factor out a negative from the top here and then cancel those out, and I'm left with negative 1 over 4a plus 3. Maybe I should say the limit. I'm going to rewrite that. This is the limit as x approaches a of negative 1 divided by 4a plus 3. That's 4x plus 3. This is a limit we can evaluate. As the x gets close to a, this x turns into an a, and we get 4a plus 3 squared. 4a plus 3 times 4a plus 3. So this huge mess right here, this gives me f prime of a. F prime of a. This is really helpful. This is a good thing. Now I can figure out any derivative like f prime of 2 just by looking at this and being like, oh, I'll change all the a's into 2. So now this becomes a really easy question. This derivative is just look at this and change the a to a 2. So I got what? 8 plus 3 is 11. 11 squared is 121. So negative 1 over 121. All right. That's the end of number 5. I don't know who I'm asking. Number 6. Here's g of x. Find the derivative. Whew. All right, let's do difference quotient. I haven't done that one in a little while. Limit as h approaches 0 of f of 4 plus h minus f of 4 divided by h. And so that's f of 4 plus h is the square root of 8 plus 2h plus 1. F of 4 is the square root of 9. So what I have up top is the square root of 9 plus 2h minus 3, and on the bottom an h. So the trick we do when we have a square root like this is multiply by the conjugate. So we're going to multiply by the square root of 9 plus 2h plus 3. And by doing that, I end up with the difference of squares. I get 9 plus 2h minus 9 divided by h times square root of 9 plus 2h plus 3. So up top, 9, let's get my canceling out color, plus 9 minus 9. Now I just have 2h on top, h and 2h. Beautiful. So what I'm left with is the limit. Well, let's not use green. That h was canceled. Is the limit as h approaches 0 of 2 divided by the square root of 9 plus 2h plus 3. H goes to 0, that's just 9 plus 0. Square root of 9 is 3. 3 plus 3 is 6. So that's 2/6, in other words, 1/3. So f prime of 4 is just 1/3. Find the equation of the tangent line to x. Okay, so this right will be our slope. So we got m equals 1/3. X equals 4. Y is f of 4, which is square root of 8 plus 1, which is 3. So now I got y minus y1 equals m times x minus x1. So y equals 1/3 x. Let's see, that's minus 4/3 plus 9/3 is plus 5/3. Did I do that right? I think so. So this right here is the equation of our tangent line at this point. All right, getting down close to the end. This one was pretty hard. So maybe I'll just start doing it. Let's see, which way should we guess? Again, it doesn't matter. I'm going to use the difference quotient again. Although you will see that you can do it either way. Actually, maybe just I did the difference quotient last time. Let's do the definition of the derivative. So the limit as x approaches a of, I'm just going to call this f of x for the sake of my formula. I don't like having h's floating around in two different places. F of x minus f of a divided by x minus a. Okay, f of x, really h of x in this case, is x to the 1/3 power. Let's try that again. Is x to the 1/3 power divided by 2. And f of a is x, or is a to the 1/3 power divided by 2. And then that whole thing is divided by x minus a. So we could rewrite this. We could pull out the 1/2, and you're left with x to the 1/3 minus a to the 1/3 over x minus a. And you really want to get rid of these 1/3. That's kind of what the trick is. So you might be tempted to try to cube the top and the bottom, but that won't end up working. What you'll have to do is take advantage of the difference of cubes formula. So maybe in another color off here to the side, I'm going to say that x cubed minus a cubed is equal to x minus a times x squared plus ax plus a squared. So this is our difference of cubes formula. So I'm going to use this formula, except my x is going to be x to the 1/3, and my a is going to be a to the 1/3. So when I cube it, I end up with just an x and an a up top. What I'm trying to say is that I'm going to multiply the top and the bottom of this equation by all this stuff. So x to the 2/3 plus a to the a, let's write it like this. No, let's not write it like that. That'll be confusing. A to the 1/3, x to the 1/3 plus a to the 2/3. And I need to have that on the bottom as well. X to the 2/3 plus a to the 1/3, x to the 1/3 plus a to the 2/3. So what we get if we do that is you still got that 1/2 up top. We'll deal with that later. But if you multiply all these out, you're left with just x minus a. So that was why we carefully chose what we chose. And on the bottom, oh look, we also have an x minus a. Unfortunately, we also have all this mess. X to the 2/3 plus a to the 1/3, x to the 1/3 plus a to the 2/3. But this is good because now we can cancel these guys out. And what we can say is that this is equal to the limit as x approaches a of, let's write this like this, 1 divided by 2 times x to the 2/3 plus x to the 1/3, a to the 1/3 plus a to the 2/3. And we can evaluate this limit, turn all the x's into a's, and what you get is 1 divided by 2 times a to the 2/3 plus a to the 2/3 plus a to the 2/3, 3a to the 2/3. In other words, we get 1 over 6a to the 2/3 power, which maybe I'll write or 1 over 6 times the cubed root of a squared. Wow. Okay, find the equation of the tangent line to this guy at x equals 8. So what we need for that is we need to know what is h prime of 8. We just figured out h prime of a is this, so h prime of 8 would be 1 divided by 6 times the cubed root of 8 squared. Wow. Okay, the cubed root of 8 is 2, 2 squared is 4, 6 times 4 is 24. So we get that our slope is 1/24th. And we need a point. Oh, they gave us a point. So we got, this is x1, and we need to know y1. y1 is what you get when you stick 8 up into this. So y1 is the cubed root of 8 over 2, which is 2 over 2, which is 1. So to find the equation of the tangent line, you get y minus y1 equals m times x minus x1. So if you distribute that through, well, maybe I'll do arrow. So y equals 1/24th x, and then that is what, negative 1/3, but if you add 1, you get positive 2/3. And this right here is our final answer. And good Lord, that's finally the end of this worksheet. So there you go.